Welcome to Microsoft Build 2017. I'm Stefan Froelich, and I'm a dev on the Core Bluetooth team.
I'm Frank Georgeni. I'm also a dev on the Core Bluetooth team.
This is part one of a three-part video series we're doing. In this part, we're going to introduce the Bluetooth LE Explorer app.
In part two, I'm going to show you some of the code used to connect to an unpaired Bluetooth peripheral. And in part three, I'm going to show you how to write your own GATT server or a virtual peripheral.
So the Bluetooth LE Explorer app allows you to be both a client connecting to GATT servers out there, enumerating them and interacting with them. And it'll also allow you to be a GATT virtual peripheral with just a few button clicks.
We asked Stefan to share this application with you, our developers, because it was so helpful for us when we were developing these features for the Creators Update. It allows us to explore the behavior between the peripheral and the OS, or between the client when we're the peripheral.
So the app will be in the store. Actually, it is already in the store for the Creators Update. And we will make all the source code open source so you can download it, play with it, fix some of our bugs, and create some of your own virtual peripherals.
Cool. The other thing we'll be showing you is the virtual sniffer that we built. Now, we built this because we wanted to understand the commands going between the radio or between our platform and the radio. It allowed us to understand whether the issues were ours or they were with the external device. It was so helpful for us, we've also decided to share that with you, and it'll be on our blog in the coming month.
All right, let's jump into the demo. So on my screen, you can see that we have the Bluetooth Explorer up and running. On the left, there are two menu items. We see Discover and Pair, and we see Virtual Peripheral. The Virtual Peripheral is crossed out because on this particular laptop, it has a Bluetooth chip that doesn't support it. So this is a good way to show the user that they can't do that feature on this particular laptop. And in a future session, Frank will show you exactly how to do that programmatically. For this session, we're going to do the client side on my screen. And Frank, could you start a server for us and show us how to do that?
Yeah, let's switch to my PC. And on this laptop, you'll see that Virtual Peripheral was not struck out. It was, in fact, able for me to click. And you'll see that it shows Add Service. Now, we have two predefined services. The first is the battery service, which is the standard service defined by the SIG, and it will present the battery's laptop. However, for today's demo, we're going to show you the Microsoft service. And that's because we have 5 characteristics we want to show the different behaviors of. The first characteristic is a read characteristic. It's pretty straightforward. The second characteristic is a write and a write without response characteristic.
So what's the difference between write and write without response?
Well, in the case of write, the client gets an acknowledgement from the server whether the write was successful or not. And the write without response, there's no acknowledgement. It's just fire and forget.
So as a developer, do I need to do any of that acknowledgement myself, or does the stack handle it automatically?
The stack handles it automatically when you complete the deferral for the write request. But that is an interesting point. One gotcha is don't set a breakpoint in there because there's a protocol required timeout. So if you have a breakpoint, we'll fail the request because the deferral wasn't completed in time.
Great. All right, any other characteristics we have?
Yeah, we have a read with notifications and we have a read with indications.
Indications and notifications sound really similar. What's the difference there?
They are very similar. The notification has no acknowledgement from the client. So we will notify you when the value is changed. And on the indication, the client will respond indicating that they've received that notification.
So it's kind of like events in C#?
Yeah, in fact, that's how we presented them to you, our developers. We presented them as events, so it would make it simple for coding and it's something you're used to handling.
Do I, as a developer, have to write the acknowledgement for indications, or does the stack handle that itself again?
Yeah, the stack handles it for them as well again.
Great.
Yeah, and the last is another read characteristic, but this time we've put a lot of data in it, more data than can fit in a Bluetooth packet. And on other platforms, the developer is responsible for handling these reads iteratively. But on Windows, we do it all for you. They just call one read and the platform takes care of the multiple reads under the covers.
Great. All right, are you advertising?
I am now. Let's switch back to your machine.
All right, great. So again, we're on the client view, and all we need to do to discover the devices around here is click Start. So now we can see there's quite a few different devices in the area, and that's not abnormal. There's lots of Bluetooth LE devices, and we can see a lot of them. So here we see GATDemo2, that's Frank's computer. We can see the address. We can see if we're currently connected or not. And we can see if we're currently paired or not. And the paired is interesting because with the creator's update, we actually enabled connecting to unpaired devices, which we didn't support before. So we're just going to go ahead and click on GATDemo2 and connect to Frank's computer.
Stefan, I noticed that the service count was 0 when you were connecting, yet we know that I have at least one service published.
Yeah, so that can happen when the advertisement doesn't always have the service count in it. It depends on how much is actually in the advertisement, depending on the size of the packet.
Ah, got it.
So let me just scan here again. It looks like the app crashed initially.
Well, I'm glad you're making it open source. We can have all of our friendly developers in the community fix that.
That's right. All right, so here are the 4 services that we just talked about. So you had 1, and we have 4 services show up now. That's because Windows comes with 3 services predefined: the generic access service, generic attribute service, and the device information service. Those always come with Windows when you're making a virtual peripheral. The 4th service is the one, our custom service that you created. Now, the first 3 have names that we can actually read, readable names, and that's because they are services that the Bluetooth SIG has well-known GUIDs for. The last one is a custom GUID that we created for our service, so we don't have a good name for it. Here we see the 5 different characteristics underneath your service, just like you showed earlier. So we're going to go ahead and get the details on the first one. So here are some of the details on the service. We see that it's handle 18. We have a value of 0A in hex. That's been read. And hex is currently checked in the radio buttons. What happens here is that a GAT characteristic, like Frank set up, actually has a presentation format in it as well. So it can say I'm a string or I'm an int.
Thanks for catching that. I forgot to mention.
Yeah, no problem. So this particular one, he's sending over as an int, so we're going to display it as a hex. We also see that the properties on this particular characteristic are read-only. So if I go ahead and click the read button, what's going to happen here is it's going to send a GAT read over to Frank. The server, the way we have it coded, is that it'll take that read, actually change its value internally, and send us back a new value. It makes for a pretty good demo. So we click read, we can see it changed to 12. So that worked just the way it needs to. So we're going to go back and go to our next characteristic. So this is our write characteristic, just like Frank showed us earlier. Again, we have our handle. This one is 22. We have our UI elements for write, so a text box, a write button, and we can write in 3 different formats: decimal, hex, and UTF-8. And the properties of this characteristic are write and write without response. So we're going to go ahead and write, to Frank. We'll make it a UTF-8 string and send it over. Did you get that?
I did. I got hello, Frank.
Perfect.
Thanks.
All right, so let's go back and go into our notification and indication characteristics. So here is our notification characteristic. Very similar to the previous ones. We have a handle value. We also have the value we read initially, which was hello world. And this one, if you notice, the radio button that was selected was the UTF-8 radio button. That's because this characteristic is set up to tell us that the presentation format is a UTF-8 string. We see that the properties are read and notify, just like we said earlier. And we have 2 new UI elements. We have a checkbox that says use Windows notifications. What this does is actually receives the GAT notification and then turns it into a toast from Windows. Makes it a little bit easier to see. The only thing we have to do now is register for notifications, and then we should see the string that Frank sent us. Do you want to signal us, Frank?
Yeah, I'll send a notification.
Perfect. Hello, Stefan. Hi, Frank.
Hey.
So we can see that the toast popped up through the Windows notification, and we see that the read value changed to hello, Stefan. Pretty straightforward. So now we're going to go back and click on our indication characteristic. So here again, the first read was a hello world as a UTF-8 string. This time we won't register for Windows notifications or sign up for Windows notifications. We'll just register for our standard GAT notifications. And keep an eye on the read text box. Frank, do you want to signal us?
I will.
Having fun. I'm having tons of fun.
Yeah, me too.
All right, so let's go back. And our last characteristic is this big, long read long characteristic. So underneath the covers, as Frank mentioned, the data that the server is telling us requires multiple reads to handle. So if you go ahead and download the app and look at the source code, you can see how to do that yourself. So Frank, do you want to show us the logs we've been collecting?
Yeah, not a problem. So we'll switch to my PC. I'm just going to minimize the app here. And what I did before the session started so that we could record this is I launched the Bluetooth Virtual Sniffer application, just double-clicking on this. That opened this virtual sniffer window here, the second dialog on the screen. Now, because I have the Compro protocol analysis software installed, it auto-launched it and connected to that session. I just had to click record previously. Now, I did this ahead of time so I could show you the logs, and then you can just view the logs in here. So these were recorded live, and you can see like one of the last things that we did was the write request and the write response. The other thing you can do, just so you see that it's live, is I'm going to switch to the HCI tab. This is where the commands go to the radio, and we can turn off the service and see that we'll actually disable the advertisements. And it's the one above. There we go. So we've disabled advertising when the application stopped. It's pretty straightforward, and it really helps us understand the behavior between our application and the OS and the remote devices.
Great. So double check our blog. We will have links for all of these things here. So we'll have a link to the Bluetooth LE Explorer that we started out with. We'll have a link to the virtual sniffer that Frank just showed us. Of course, we'll have all the documentation, all the samples, and a link to the frontline analyzer tool you need to look at the logs.
Thanks for joining us today, and don't forget to check out our other sessions, Part 2 and Part 3, where you show you how to build a client and a server. Thanks for joining us.